Okay, so it says, what is the volume of the prism? So you're looking at this prism right here. This is your question. And why is that important? Why is the word that I just circled important? Okay? Okay, so we're finding the volume. What is the formula to find volume? Isaac? All right, so there are a couple different ways that you can solve this problem. Any chance that I get that I do not have to use fractions, I do not. So when I solved this, I changed all these to decimals. And I ended up with 20.3125. All right. However, if you did not change them to decimals, you ended up with 5 halves times 5 halves times 13 fourths. Okay, so far so good. How many of you guys changed them to decimals? Okay, and that's fine. How many of you guys obviously kept them as fractions? All right, so when you multiply 5 times 13, what do you get? So 325, and then when you do 2 times 2 times 4, what do you get? 16. All right, do we have the option to have 325/16 as an answer? So what do we need to do with that? Brayden? Okay, so I'm going to come over here. And I'm left with 20 and 5/16. Both of these are the exact same. And technically you can stop here. You could have probably stopped here because how many of these have a 2 in the tens place? Just one. Okay, so definitely use your answer choices again when you have them to help you out. So the correct answer for this one is D. How many of you guys got that one correct? Okay. If you didn't get it correct, hopefully you see where you might have gone wrong. All right, let's look at the next one. So Susie is wrapping a cubed shaped box and wants to make sure she has enough wrapping paper. The net for the box is shown. What is the area she needs to cover? All right, so cube shaped box. Why is that important? Brayden. Okay, so it means all sides are equal because they're all made up of what shape? A square. All right. The word net. What does the word net mean? What does that word mean?
It's like taken apart. It's a shape taken apart.
What type of shape?
A 3D.
And so it's taken from a 3D shape to a what kind of shape?
To a 2D shape.
Right. So a net is the two-dimensional representation of a 3D figure. All right, and then we need to know what is the area. Now, please do not get confused with this. Because if you're thinking, well, I only have to find area, what answer did you pick? A. That is not right. Why is A not correct? Brayden?
Because that's only the volume of the first.
Not volume.
Or area of the first square, and not all of them.
Right, so it's only the area of one of those squares. So that is why you need to understand that this is a surface area question. So when you do 4.5 times 4.5, you end up with 20 and 2500. So that is the area of one square. We have to cover all of the squares. So therefore, what do we know about all the squares now? Caleb? So they're all 20.25 or 20 and 25 hundredths of an inch. So we can either multiply or we can add them. When you multiplied or added, what did you get? When you multiplied or added, what did you get? Leah?
I got C.
So you got 121.5 inches squared. Yes. That is the correct answer. All right, so how did we do with this? Okay, not too many thumbs up. Do you see where you went wrong? Okay, was it a minor error? Did you look? How many of you guys picked A? Okay. Make sure you understand what the whole thing is asking. All right, go ahead. Flip this over. Now we're not going to be able to put them in the little sleeves back there because they're so big, but you still need to do the the bottom, middle, or top and put your name on it. Have one person from your group collect them and put them on the back table. Quickly. Get out the note sheet that I passed out to you. You can fold it in half. And then you can use like a highlighter, or if you just want to use like a different color pen, you can do that for your notes today. All right, so independent, dependent variable, or variables, are kind of like all of Unit 6 combined, because you need a little bit of understanding of expressions, of equations, substituting, unknown numbers, but you also are going to be dealing with unit rates, unit price, and ratios. So it's kind of a combination of a couple different things. So do not make this brain surgery. Like we're skipping right over rocket science and we're going straight to brain surgery. Don't do it. This is very easy if you keep it simple. If you try to make this complicated and you try to look for like the super hard answers, it is going to be hard. But if you just apply what you know and what you've learned, it is not that hard. Okay? So do not make this difficult. First period made this extremely difficult, and I don't know why. It should not be difficult at all. All right, so independent variables is the cause to change the dependent variable. So it changes your dependent variable. Okay, so your independent variable changes your dependent variable. The dependent variable, the changes are caused by the independent variable. All right, so we're going to look at a situation. We're going to talk about the independent, the dependent, how they apply, and as well, how many of you guys know what this is called? This thing right here. How many of you guys know what that's called, Travis?
Number grid?
Nope, not a number grid. Kind of, sort of, but there's more of a mathematical name for it.
It has something to do with coordinates, right? It's a, forgot.
So it's a
Oh,
coordinate.
no, I know what it is. I know what it is. It's the y-axis. No,
It's
x
got-
and y-axis.
It's got those parts,
Yeah.
but there's still a name for it.
Oh.
Kaylee?
The coordinate plane.
It's coordinate plane or coordinate grid. So you guys last year learned about the X and the Y. You learned about quadrant 1 only. This year when we actually get to quadrants, you're going to learn about all of them. But for now, we're still just dealing with what you know. Okay, so this is nothing new for y'all. All right, so your situation is, Jackie tests how the height of a ramp affects the distance a toy car travels. All right, so again, Jackie tested how the height of the ramp affects the distance a toy car travels. Bless you. So your independent variable is your height of your ramp. So the higher the ramp is going to affect what? What is it going to affect? It's right up there. Just what is it going to affect? The what? Not the car, but something with the car. Jennifer?
The distance.
The distance. So if your ramp is lower, it's probably going to go further. If your ramp is higher, it's probably not going to go as high. Okay, so this is how you know that the height of the ramp determines the distance of your car. Does that make sense? What is the key word that you heard me say? What do you think the key word was? Garrett?
Distance.
Nope. The height of the ramp determines the distance a car can travel. Lauren? Determines. For the remainder of the time that we are dealing with independent and dependent variables, the word determines tells you you're independent to your dependent. Whatever determines the other. So that's going to be really important for you guys to remember the lingo. All right, so your independent variable is the height of the ramp. The dependent variable is the distance a car travels. So looking at our coordinate grid, the height of the ramp is the name of your x-axis. So this is the name of x-axis. The distance traveled is the name of your y-axis. Now, the reason that this is important is because you might need to use your coordinate grid to help you figure out part of your independent and your dependent variables. The next two bullets are the most important thing to remember. Your independent variable is always going to be on the x-axis. So this is your independent right here. And the dependent variable is always going to be on your y-axis. So this is your dependent. It is always, 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 always going to be there. No matter what is going on, no matter what the situation is, your independent will always fall on the x, and your dependent will always fall on the y. All right, give me a thumbs up so I know we can move on. All right, go ahead and open up your notes. So the top says match the independent variable to the dependent variables with an arrow. So all four situations on the top are your independent variables. All four situations on the bottom are your dependent variables. So the ones on the top determine the ones on the bottom. So if I'm looking at the amount of sunlight, is that going to go with your test grade, the height of a plant, the amount of profit, or your calories burned? Which one does the amount of sunlight determine? Jeffrey? The height of your plant. So the more sunlight you have, the higher your plant or the bigger your plant is going to get. Okay, so the next one, the time spent studying, is that going to be your determine your test grade, determine the amount of profit, or determine your calories burned? Harley? Yes. Okay, so the number or the minutes spent exercising, is that going to determine the amount of profit, or is that going to determine the amount of calories burned? Ellie? Yes. And then obviously the number of tickets sold determines the amount of profit you make. Okay, so do you guys see how using that language makes it a little bit easier to make the connection between the two? So that's what I want you doing when you're working on, especially tomorrow when you're doing your group activity, but you're going to be working in groups. Everybody's going to need to understand the lingo of the independent determines the dependent. All right, so we are given a situation. We are essentially going to identify our independent dependent variables. We're going to identify what the relationship between the independent dependent variable is. We are going to graph it. We are going to fill out a table, and we are going to write an equation. Okay? So that is what we're going to be doing on this bottom part. The reason we're going to be doing this is because Today we're doing it together. Tomorrow you're doing it on your own. So if you have questions while we're going through this, I need you to ask, be like, Miss Kinney, I don't understand why we did this. Miss Kinney, I don't understand why we did this. Miss Kinney, what are you doing? Miss Kinney? So obviously make them reasonable questions, but definitely ask your questions. So our situation is Carly earns $9.50 for every hour she works. I'm going to read it again. Carly earns $9.50 for every hour she works. So what is our situation? What's important in our situation? Garrett?
$9.50 every hour.
Okay, so essentially she's making $9 per hour. Where have you heard that before? $9 per 1 hour. $9 per hour. Where have you heard that before? Harley? Yes. So a lot of times you are going to be looking or starting with your unit rate. That is always going to be the first thing that you put into your table. You good? All right, so now we have to figure out which one is our independent variable and which one is our dependent variable. So which one determines what? Does how much you make determine how much she gets paid? Does that make sense? So we know how much she makes, right? So is that going to determine, though, how much she got paid? No, why not?
Because they're both the same thing.
Exactly. They're both the same thing. So if I know that she makes $9.50, that's not going to tell me how much she makes. What do I need to know in order to find out how much she makes? What do I need to know? Noah?
How many hours she works?
Yes. So our independent variable would be hours worked. Now, do you guys understand why that is the independent variable? Because if she only works 1 hour, how much does she make? $9. Yeah, $9.50. If she works 17 hours, she's obviously going to make a lot more money. Does that make sense? So the number of hours determines her what? All right, so money earned. All right, so my independent variable, is it going on the X or the Y? So which one is this going to go on? The hours worked, the X or the Y? Yes, this is my X axis. And then obviously the money earned is going to be my Y axis. All right, so before we fill out the question down here, let's slide over to our coordinate grid. If you guys just told me that the hours worked goes on my X axis and the money earned goes on my Y, I'm going to go ahead and put that information down here. All right, so give me a thumbs up once you have that, because I don't want to go too fast through this. Okay, so let's slide over to what is the relationship between the independent and the dependent variable? What do you think, Brayden?
Both of them determine how much or how many minutes. So like they have a relationship because if she works more than 1 hour, she makes more money. So I guess they affect each other if they change.
So you're partially right. You are right in the fact that if she works a certain number of hours, she makes money.
Yeah,
So
but if she doesn't work a full hour, then she wouldn't make that. But if she made more money, you could determine off how much money she made by how many hours she worked.
okay, so I'm going to modify what you said, but you are correct. So essentially, what Brayden is trying to say is the more hours she works, the more money she will make. That's what you're trying to say, right, Brayden?
Yes.
All right. And does that make sense to you guys? Because again, the number of hours determines how much she makes. So like Brayden said, if she only works an hour, she's only gonna make $9.50. If she works a lot of hours, she's gonna make a lot more money. So how do we feel on the first two parts, the graph and kind of determining what the relationship is? Feel okay? All right, let's slide over to the table. So it says you can show the relationship between the independent and dependent variable in a table and an equation. So in our table, do we already know what the x and the y are representing?
Yes.
All right, Garrett, what is the x representing? Nope. What is the x representing? Nope. Don't change it. Look at the information we've written about the independent and the dependent.
Hourly work.
Yes. All right, and then what does the y represent? All right, so we're going to use the first example of the 1 hour. We know she makes $9.50, right? So what if she worked 3 hours? How would we figure out how much she's going to earn? What would we do? Jeffrey? Okay, so you're going to do $9.50 times 3. And you end up with $28.50. Okay? So essentially, we multiplied the number of hours times the 950 to get that answer, right? You guys agree? Yep. All right. So what about if we said 9 hours? What would we do to figure out how much money she's going to make? Isaac? Okay, so multiply 9 times $9.50 and tell me what you get. You get $85.50. And over here, we multiplied the 950 times the 9. So what is the consistent thing that we are multiplying by? Like, what is the same thing? Brayden? $9.50. All right, so I have a question. This should look very similar to something we have already done this year. So we said 1 was $9.50, right? 3 was $28.50.
Yes.
And 9 was $85.50. Good Lord. All right, so what happens if I multiply, sorry, not multiply, I just told you. What would we get if we multiplied 2 times 950? She worked 2 hours. What would we get? Addison?
19.
You would get $19. So what happens if she worked 4 hours? What would we get? Garrett? Even? All right. So essentially, we are doing the same thing for everything in this table. If this table went on forever, what would we always, 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 always be multiplying by?
X times Y.
Close. Close. Not x times y, but x times what to give us y. So we essentially, from, like, how do I say this without giving you the answer? What's the original scenario that we were given? How much is?
And then the money she earned. And then how much she made was how many hours she worked.
Right. So our original was in 1 hour she makes $9.50, right? So then when we found 3 hours, what did we do with the 3? Okay, do you hear what he just said? We multiplied the 1 by 3, technically, and we multiplied the 950 by 3. What does that look like that we have already covered this year? What does it look like? Because here, we multiply by 4, and we multiply by 4. What does it look like? Gotta take it way back. I like that Raiden is at least trying to look in a notebook. He's not gonna find it because it's from Unit 2. Unit 2. Jeffrey?
Unit rate.
Not unit rate. Close though. Bailey?
Ratios.
Yes. This is a ratio table. That's all it is. It is just a ratio table. Because remember, when you're doing ratio tables, you're essentially finding equivalent what? Equivalent ratios. Whatever you do to the one side, ooh, got choked up. You have to do to the other side. So originally, going back to what Noah said, you have to do 950 times x to give you y. That is where we are going. So our equation to wrap up this little table scenario is y equals 9.5x. Are you guys all asleep in first period? Is that why my first period is so special sometimes? Are you asleep in first period, Garrett?
No, I'm really tired.
You're just really tired? Y'all stay up too late last night?
No. Yeah. I stayed up until like 9:30.
I went to sleep early yesterday.
Hey, that's late for me, so. All right, so let's get back focused. So the very last thing that you have to be able to do is take the information from your table and put it into a graph. Now, we know what our x is, we know what our y is, correct? So in our table, so we're gonna graph the first row. We're gonna go to 1, and we're gonna go to 950. So I'm gonna go to the right 1 and up to 950, which is like right there. It's pretty close to that 9 in that first line. So then the next set of points that we have are what? So looking at your table, what's the next set of points?
3 hours and 28.
Okay, so 3 hours and 28.50. So I'm gonna go 3 to the right, because you always go x first. X is always to the right. And then I'm gonna go up 28.50, which is gonna be right above the 27. All right, and then the last one that we put in our graph is what?
9 hours. 85 hours.
Okay, so I'm gonna go to the right 9, and I'm gonna go all the way up here to 85.50, which is about there. Now, this is a very good way for you to check to make sure you did this correct, because ultimately, if you did, these dots end up on a straight line. And obviously I can't draw a straight line without a ruler and everything, but you get the point. They're in a straight line. So let's say that I wanted to put into my chart 5. And I'm saying, okay, 5 times 5. It's gonna be a 0, it's gonna be a 5. So I'm saying that my answer for 5 hours of work, she makes $45.50. So I'm gonna slide over in between the 3 and the 6, and I'm gonna go up to the 45.50. And it's a little off. So what do I know I did there? Did I do my math wrong? Well, if it's not on the line, then I must have done my math wrong. Did I do my math right?
Yes.
No, it's wrong. It should be 49.50, right?
47.
47.50. I knew it was one of those. So it's off a little bit. So if your dot is not on your line, you know that your math is wrong. This is not right because it does not fall on the line. It's got to fall perfectly on that line. All right, go ahead, glue this into your notebook on your notes page. And then we're gonna move to pencils for this next Yes, but not right now. You can do it when we're done. All right, so the next page in your notebook, please go ahead and title it independent/dependent cool down. Give me a thumbs up once you have that done, and we're gonna turn the page. You have about 10 seconds. All right. And then you have this page. Independence/dependence, classwork/homework. And that is where this paper is going to go. Not right now, obviously, but. Give me a thumbs up when you have this done. All right, so we are going to essentially start solving and putting these into tables, and then we're also going to be graphing them. Some of these are going to require us to write our own equations. Some of these are going to give us our equations. We just have to solve it. So this is where I get really confused with students, because this is going to be very similar to what you see on the test. They're going to give you a table. They're going to give you an equation, and they're going to say which one is true. Or which one is the independent, dependent variable equation, something or other. All you have to do here is plug in your information. So essentially for this first one, do you know the value of x? Does the table tell you what the value of x is?
Yes.
Yes, it does. Does it tell you what the value of y is? For the first one? Yes, it does. So essentially for this one, you are simply substituting in, well, for all of them, you're substituting in your x, and it's got to equal your y. So, for example, this one, it's 2 times 5 plus 1. Well, what's 2 times 5?
10.
Plus 1. So then we know that's true, right? So then, moving forward, all we have to do is what? To fill out the rest of this table. What do we have to do, Jeffrey?
Do the same formula, 2 times whatever x is, and add 1 after you do the product.
Yes. So you essentially are using the exact same equation for everything else in this table. You are simply plugging in what your value of x is and figuring out what your value of y is going to be. So the next one is going to be 2 times 4 plus 1. Well, what's 2 times 4? 8 plus 1?
9.
All right. So what is the next one? And please, please, please write down everything I'm writing down. If you don't write this down, I don't know why. All right, so what is the next one going to be? Kaylee, wake up. Wake up, sweetie. Well, so do I, but we're all in this together. Let's go, sit up. Travis.
2 times 3 plus 1.
So 2 times 3 plus 1. Well, what is 2 times 3?
6,
Plus 1?
7.
Okay. What is the next one?
2 times 2 plus 1.
So 2 times 2.
Plus 1.
Well, what is 2 times 2?
4.
Plus 1.
5.
And then the last one, I'm going to write it over here. 2 times 1 plus 1 equals, well, what's 2 times 1?
2.
Plus 1?
3.
All right, do you notice a pattern?
Yes.
Ryan, what's the pattern?
All the answers just adding to it.
Adding to everything or decreasing? We're decreasing by what? 2. All right, Ryan, what do you notice about the x column? What's going on with our x numbers? Are they increasing or decreasing? By 1. And the reason I'm asking this is because this is also very important, what you're going to notice about the points. So now we're going to plot our points. So we're going to do 5 first, 11 second. So I'm going to go 5 to the right, I'm gonna go up to 11. What is the next set of points that I'm going to plot? So I did 5, 11. So what is the next point I'm gonna plot, Lauren?
4 to 9.
Okay, so am I going to the right or up first?
To the right.
How many?
To 4.
All right,
By 9.
up to 9. All right, what's the next one? What's the next one I'm gonna do, Nevaeh?
3 to 7.
So 3, what?
To the right.
Thank you. And 7 up? Okay. What's the next one? Travis?
2, to the right 2, and then up 5.
And then the last one is 1 to the right and up 3. So what do you notice on your graph? So you go over 1, up 2, over 1, up 2, over 1, up 2, over 1, up 2. Isn't that the same pattern as our table?
Yes.
One's decreasing by 1 and one is decreasing by 2. And then if you draw your line,
Straight.
you should have a straight line. All right, so what do we think about this? Okay, cool. Let's go ahead and go on to the next one. So y equals x minus 2. So how do we know if this one is correct? How do we know if the x and the y that they've given us is correct? Garrett, what do we need to do?
Solve the equation.
Yeah, so what am I gonna plug in?
You're gonna plug in, wait, 2 minus,
Nope.
no, 7 minus 2 equals 5.
Yes. So our x is 7, our y is 5. We know that that equals. So moving forward, now what do we do? What do we do? What are we gonna do? What are we gonna do? Sebastian?
6 minus 2.
Yep, so we're just gonna plug in our x's and then solve the problem. So 6 minus 2 is going to give us 4. All right, what's the next thing? What do we do next? Caleb?
5 minus 2.
Equals. All right, what's the next thing? Bella?
4 minus 2.
Perfect. And the last one is 3 minus 2 equals 1. All right, and then how do we check to make sure that we have done this correctly? Brayden?
You have to put them on the table, and if they're in a line, if they're correct.
The coordinate grid?
Yeah, the
Okay.
coordinate, that one's called this one.
All right, do we go x or y first? X or y first? We go x first, so is that going to the right or going up? Going to the right. So for here, I'm going to go 7 to the right, and I'm going to go up 5. Then for the next one, 6, 4, I'm going to go 6 to the right, up 4. The next one, I'm going to go 5 to the right, up 3. The next one, 4 to the right, up 2. And the last one, 3 to the right, up 1. Draw our line, and we notice it is what? Straight line. All of our dots are in place. We also are increasing by 1, or going over 1, up 1, over 1, up 1. What do we notice about the numbers in our table? Right, so both of them are decreasing by 1. All right, so how do we feel about this one? Starting to make a little bit more sense table-wise. All right, number 3, it says cost is ticket plus $2 fee, handling fee. What do we do? Because we're missing a whole bunch of things. I don't know what to do. I'm about to crumble up my paper and just call it a day. Because everything is different from the first 2 things that we did, right? I don't see an equation. I don't see an x. I don't see a y. How do I solve this problem? Garrett?
So on the y coordinate, it says the cost. So the cost would be the y, and then the ticket price would be the x.
Right. So if you remember back in the notes that we took, we labeled the sides, right? And this is where that comes in to help you because the what is always the x axis. Lauren?
The bottom
Nope.
to the right.
Nope. The independent variable is always the x-axis. So if this is the ticket price, which one is my x? Which one? No. Which one is my x? Yes. And then obviously the C, which is the cost or the label of my y, is my y. So now it should be a little bit easier because now we know what our x is, we know what our y is. The other thing, Kaylee, I'm gonna make you stand up. Sit up, please. The other thing is we do not have a equation. So how do we solve this? How do we write our equation? How do we write our equation? Right, but that's not an equation. So essentially, it tells you exactly how to write it. You're right, but using variables is what we want. Because it's not always going to be 4 and 6, right? So, hold on. What's the C represent in the sentence above?
The cost.
Right. So the cost, what does the word is mean in math? What does the word is mean in math? Leah? Nope. Nope. No, y'all, I wrote it on the paper. The cost is, so the cost is going to equal what? Jeffrey? No, we don't have an x. It's going to equal what? You have to use what is on your paper. We've already used the C. We know that the cost is going to equal what? Garrett?
Ticket price.
Which is what? No, y'all. What? No.
No, independent.
Okay, hold on, wait. Everyone, close the brain. Close it. Because we're not doing brain surgery, remember? We are doing exactly the same thing as the first two, but they have completely annihilated us because they did what? What did they change? Jeffrey. If you read this, cost is the ticket price plus $2. All you have to do, guys, is read the information that they give you. And yes, I want you to use the T and the C because that is what you are seeing. You are seeing the T and you are seeing the C. Yes, we've labeled them as the X and the Y, but you need to understand what the T is and what the C is. So now, like Nevaeh said originally, 4 plus 2 is going to give us 6. You are correct. We're just going to plug that in, and we know we're right. So how do we figure out the next one? What do we do? Jeffrey. Okay, what do we do for the next one? Addison? Equals. What do we do for the next one? Brayden?
10 plus 2.
Equals.
12.
And for the last one?
12 plus 2.
Equals.
14.
All right, let's go ahead and graph it. So which one are we doing first, the 4 or the 6? The 4 or the 6? Jeffrey? All right, so I'm going to go 4 to the right. Well, actually, yeah, I'm going to go 4 to the right. I'm going to go up 6. What do I do next? Someone other than Jeffrey, Garrett, and Nevaeh. Caleb.
Number 6 to the right. And up 8.
Okay. What's next? Ryan.
10 to the right.
Not 10.
8 to the right.
And
10 up.
okay. What's next? Leah F. We're just going in patterns. So we've done 4, we've done 6, we've done 8. What comes next? You guys have got to be able to follow along. Akira.
10 to the right.
And what?
About 12.
Okay. Kaylee, what's the last one?
14.
Nope.
9 and 12.
Which direction? And then how many am I going up?
10.
Nope. What does our box say? What does our table say?
12.
So 12 to the right, and then how many up? Yes. Again, y'all have got to be able to pay attention. All right. Homework. 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 So the back side is all homework and the right side is all homework. On this green piece of paper, this is your cool down. Please make sure you put your first and your last name on this and you turn it into the bin. You're welcome. When you are finished, get started on your homework. You can do all of your work right on your homework page. You're welcome. You do not have to do any of your work in your notebook. Again, also, if you want, you may use your notes to help you with your cool down today. So the notes that we took first at the beginning, you can use those to help you. All right, go ahead and get started. Can't talk. Go ahead and get started.